started.
Hello and welcome to the Wood Carbon Seminars. This is the follow-up discussion session to the third presentation in the webinar series called Tracking Carbon in North America. My name is Monica Huang and I work for the Carbon Leadership Forum. I'm the one who's coordinating these webinars, and I'm going to go over some introductory logistics before we start for today. So here's the agenda for today. I'll go over logistics, the disclaimer, an introduction to the Carbon Leadership Forum, introduction to the Wood Carbon Seminars, and then I'll pass it on to Kate for the discussion session. First of all, this webinar is being recorded. We will publish the recording online. All attendees should be muted, so please do not unmute yourself or share your screen or share your webcam. For the chat window, if you type something into the chat box, it will go only to Kate, who will ignore it because she's ignoring the discussion. But if you have questions for the speakers, you can type them into the chat box and we'll collect the questions from the chat log after the webinar. We're going to publish a Q&A document at the end of the webinar series answering all the questions submitted by the audience, or as many as possible, with the help of the speakers and or other wood experts. That was our this is our disclaimer slide. And then for a quick introduction to the CLF, the Carbon Leadership Forum is a nonprofit industry academic collaborative at the University of Washington. We are architects, engineers, contractors, material suppliers, building owners, and policymakers who work collaboratively, pioneering research, creating resources, and incubating member-led initiatives for greatest collective impact. Our goal is to accelerate transformation of the building sector to radically reduce and ultimately eliminate the embodied carbon in building materials and construction. We have an active online community with various focus groups, as you can see here, with over 1,000 members and growing. And this is our sponsor slide. So thank you to the Carbon Leadership Forum sponsors. And now just a quick slide about the Wood Carbon Seminars. The Wood Carbon Seminars is supporting the Embodied Carbon Construction Calculator project, also known as the EC3 tool. This slide shows the schedule for the seminars and all the topics we have in the series. Today we're on the third session, Tracking Carbon in North America, the discussion portion. All right, so without further ado, I will pass it on to Kate.
So thank you, Monica. My name is Kate Simonen. I'm founding director of the Carbon Leadership Forum at the University of Washington. And my role in this project was as moderator of these discussions, but that's coming out of the work for the Embodied Carbon in Construction Calculator tool. So the EC3 tool was incubated at the Carbon Leadership Forum, and we're helping to advance the methodology for the data in that tool. And a key aspect of that project is looking into the stage of optimizing embodied carbon around procurement. So at the stage when you're trying to choose between products that are similar. So choosing between two glue laminated beams or choosing between two steel rebars. So, this seminar series is grown out of our interest in increasing a broader understanding about the issues of life cycle assessment data in wood products, specifically related to comparison between them. Just as a highlight, within the EC3 tool, we're taking data from environmental product declarations, and when you're looking at the results from the EC3 tool, there'll be a box and whisker chart here that shows all of the results within a product category. So one of the key things is defining what is a product category. So even within wood products, not all wood products are the same. Obviously, plywood isn't the same as a glue laminated beam. So we're separating results from environmental product declarations by category. And then we're also looking at individual environmental product declarations, embodied carbon results, and trying to understand the variability or uncertainty that we might expect within that data, and establishing a high baseline number within each category, representing sort of the top of the market, the expected high value. So we're selecting helping people to select products within the same search criteria, comparing it against a high baseline, not an average, in order to incentivize and motivate data for all of the products in the category, and then estimating some precision. And so we are using a method that we're calling the burden of the doubt, which is assuming a high value when we don't know how precise something is. So within this general understanding of how data is interpreted in the embodied carbon and construction calculator, the wood has a really interesting challenge because of the biogenic carbon impact. And so one key aspect of this seminar series is to try and help us better understand both the variation within wood products and the carbon itself that's stored in wood products and how that relates to the carbon and biogenic carbon in the forest. So as we've talked about, there are tools that are used in life cycle assessment in the building sector, some of which are explicitly whole building life cycle assessment tools. In particular, Tally and Athena are using unique data sets that are internally consistent over the whole life cycle of a building. And those are the tools that you should use when you're comparing between two different options, like if I'm going to compare system A that might be made out of straw bale walls and system B that's metal stud and foam insulation. Those have different life cycle impacts, and so you need to use a life cycle assessment tool. So I just want to highlight for everybody that what we're talking about here in the EC3 tool, although it uses LCA data, it is not a whole building life cycle, a total life cycle assessment. It's an embodied carbon assessment of the upfront embodied carbon emissions. And an interesting thing came out of our last session is we learned that the Athena Impact Estimator also does present the life cycle inventory results. So all the actual emissions. So users could find that data in that tool if you're looking for that. So what I would like to do is I'm going to stop the share for now and invite our guests in. So we have Lauren Cooper, Grant Domke, and Maggie Wildnauer. Hi, Grant, Maggie, and Lauren. And it looks like we did not get the feature in which everybody else's names disappear and we become big clicked here. So we're going to we have our conversation going, and you can see who else is there. So thank you all for joining us today. Today I want to talk with that in our conversation here about three main topics. So the first block of topic is I want to dive into some of the slides about carbon pools and carbon sinks that Grant was sharing and have some discussion about those. The second block of the conversation, I want to talk about how do we increase the amount of carbon that we store and the rate of carbon that we remove, and how that relates to different how we might impact that as people in the building sector. And then the third block of time, I want to dive into the LCA detail a little bit more with Maggie. So I'm going to share my screen again back here, and I want to go to slide 16 here and ask Grant for some help here. So Grant, you shared these slides. I've seen these slides before, and I'm wanting to understand a little bit more of what's going on in here and how these numbers are created. You told me there's something like a FIA survey. Do people really go out on the ground and measure all the trees in America? What's going on?
Yeah, so this table really reflects more than 125,000 plots in the US are measured every 5 to 10 years. And so this is really a reflection of a lot of hard work by field crews going out and measuring plots on all forest land, all ownerships. And these are permanent plots. And so we can not only get a snapshot in time, which this slide reflects. So this is the carbon stocks in million metric tons of carbon. And so what this is really describing, or what this is a compilation of, is field crews going out on the ground, taking diameter measurements of trees, tree height measurements, as well as taking soil core samples, measurements of litter. And then we use all of that information collected on these plots, and we use allometrics, so models that we can relate things like diameter and height to convert those measurements into estimates of volume. And then we know things about trees related to the wood density. And so we use the specific gravity of wood and bark to then convert that volume to biomass. And then we know that there's approximately 50% of that biomass is carbon, and that can vary a little bit, but on average in the United States and in temperate forests, we use a carbon fraction of 50%. So that's really how we go from a diameter at breast height measurement to an estimate of carbon per tree. And we do similar things for dead wood litter and soil. And so we take all of that information that we collect on those 125,000 plots across the US, the islands, Alaska, and through expansion factors and a lot of math, compile these estimates of carbon stocks for each individual year. And so what you're seeing here is a total standing carbon, or the carbon that's been accumulated in the forest over time. And each estimate here reflects a snapshot in the year that's portrayed. The same is true for harvested wood products. So the harvested wood products, we've got two primary components here. We've got products in use, which reflects wood that has been harvested domestically and is used in some type of wood product. So that could be paper, which has a relatively short residence time, versus something like a 2x4, that might be used in a home, which exists in this pool for a much longer time period. So that's really the products in use component. And so we add that up, and can I have a question on that one? Yeah, sure.
Can I have a question on that one?
Yeah.
So in 1990, 1,895 million metric tons of carbon.
Yeah.
Million metric tons are in harvested wood products. Is that all the tree or just the product itself? Like, is that all the wood that was harvested? Or is it the amount that's in the product?
That only reflects the wood that was used in the product or ends up in a solid waste disposal site. So if there were tops and limbs left in the forest, those would be captured in the litter pool up above within the forest ecosystem component. Or if that was burned for energy, that would be captured in another part. Although we consider utilization for energy as instant oxidation, but those are captured in another part in the energy sector within the National Greenhouse Gas Inventory, but they are captured. So what you're seeing here, the harvested wood, is really only the material that is utilized or where a primary product is either in use or is in a solid waste disposal site of some kind.
So it would be like the roundwood log. It would be that the amount that goes into roundwood log would be the number you would put into there, and then it goes into many different places.
Roundwood,
and some of those places.
It includes chips. It would include any of the wood material that's used for any purpose. Yes, including fuel. And then, and the other important piece here is that number is a reflection of the accumulated carbon up to that point in 1990, in the same way that the carbon stock in forest really reflects hundreds of years of growth and accumulation in live biomass, but also the accumulation of live biomass that's then died and is in dead wood, litter, and soil. And so same thing with harvested wood products. So that stock estimate really reflects the accumulation of wood in use in the United States in the year 1990.
So what's the difference between then harvested wood and products in use?
So the harvested wood there is just the sum of products in use and solid waste disposal site. So it's just the sum.
Oh, I see. So 1895 is 1249 plus 646.
That's right.
Okay, so all in 1990, there's an estimate of 12,492 million metric tons of wood still hanging around in wood products.
That's right.
And there's 646 still hanging around in landfill that hasn't yet rotted.
Exactly. And about 70%
And
of the
so
landfill is considered permanent.
Okay. Okay, so this is not the change each year. And so the reason it's going up a little bit is because between 2018 and 2019, more harvested wood products existed. And
Exactly.
same in where more products in use that are still existed.
Yep,
So how come, and so soil just hangs out the same here sometimes. And so don't people go around and measure stuff? It seems hard to believe that they'd go measure stuff and it would actually add up to be exactly the same 2 years in a row.
Yeah, so they're pretty close here. And so if you look at so these are really massive numbers, right? And so there's lots of zeros at the end of these sort of numbers. So remember, this is million, so 25,000 million metric tons. So the numbers are different, and we are measuring this. What I will say is the uncertainties, particularly around the soil, are quite large. Soil is highly variable, but generally speaking, thought to be relatively stable in intact forest. And so that's sort of bared out here in these measurements. So in the same way that we measure live trees, we are taking soil cores on FIA plots, and we're remeasuring those soil cores every 10 to 20 years.
So you're saying that there's a lot of, because I've heard there's a lot of variability when you take soil plots in a plot, even you come back, the same plot might have a radically different number.
There's a lot of variability.
You take those radically different numbers.
Yep, there's a lot of variability.
But on average, they kind of
to put a spoon in the soil core itself. So it's a highly variable estimate, but we know that it's the weight of evidence suggests that it's a relatively stable pool in intact forest. And again, the FIA data, it's the largest, most consistent soil sample that I'm aware of on forests in the world, reflects that sort of stability. However, that doesn't mean that there's not a lot of variability across the landscape, and even within a plot or between the measurements in time 1 and time 2.
Okay, so I think maybe we'll go into the, Lauren, did you have anything to add to this? Or do you think that Grant got it right? Or both?
I think Grant got it right. But I just think it's interesting to point out here these different pools in forests for folks that don't work in forests all the time, and recognizing that the role of above ground biomass is actually small compared to the importance of the sum of all of these pools and the soil pool. So there's sometimes a lot of, I think going in the future, there might be a growing emphasis on soil carbon. I know that's kind of been a trend recently, a lot of questions about it and what does that mean and are there implications for management? So just kind of flagging that as an area that I think there's that does have carbon implications. I'll touch on that briefly in responding to some of the questions that came up to my work. But yeah, it's just really interesting to see the real breakdown of carbon in the forest ecosystem.
Okay, and so I think, and this has been a real clarifying part of this seminar for me, is the real distinction between pools and flux. So, and I even just got a better sense of these pools are growing over time, and that's what we want them to do, is grow over time, and the flux is measuring that rate of growth. Is that right?
Yeah, and so an important note though is that those stocks within each pool can grow, can increase at a decreasing rate, which means that we're actually, while we're increasing, if you look at, for example, here, this reflects the flux or the stock changes from 1 year to the next. So in 1990, as an example, the remaining forest land category, which is essentially all of the carbon pools just talked about, yes, exactly, less the harvested wood products, that's a reflection of the stock change between 1990 and 1991. And so that's the majority of that there, about 70 to 80% of that is a change in live biomass. So an interaction with the atmosphere where additional carbon was sequestered from the atmosphere and then stored in live trees. And the remainder of it is the accumulated carbon being transferred to another pool so that we don't lose that carbon. It hasn't been lost to the atmosphere, but it continues to accumulate in dead organic matter or soil over time. And so, yeah, this two very different tables. So I think last week when we talked, particularly around harvested wood products, the stock pool or the stock table we just showed, the stocks of harvested wood products only represent about 5% of the total carbon stocks in the US. But if you look at their contribution to the stock changes or the flux, they represent a disproportionately large amount, about 15%. So the harvested wood products pools themselves are growing substantially and are a larger contributor to annual change and annual accumulation of carbon over time. And so, yes, one is stocks, a static point in time, and this table reflects all of the interactions with the atmosphere. What it also reflects is transfers. So in this case, you see we've got forest land converted to non-forest land, which represents an emission from the forest land category. Well, that emission should then be compensated for in the other land use categories where that carbon, some of that carbon will be in a new land use category. It's not all emitted to the atmosphere. So it's important to acknowledge that this table reflects both removals from the atmosphere, emissions back to the atmosphere, but also transfers to other land use categories that we haven't included here. So there are really three things going on there.
I see, because if you convert land from one type to another and you're doing a global carbon accounting pool, you're moving it from one place to another. And it might be possible, like in the converting non-forest land to forest land, it might be a carbon beneficial thing as a whole, but what it was before might have been, if it was something super carbon beneficial, I don't know what this would be. So that's what those little B footnotes are?
Yeah, so exactly. So those reflect that, you know, these components, they're not emissions necessarily. Some of them are emissions because there's a reason there was a conversion there and why we consider that a conversion. There was a loss of tree cover in the case of a conversion from forest to other lands, which means that some of that was perhaps transferred to the harvested wood products pool. Likely some of it was burned. And so there's an emission to the atmosphere. Some of it's probably lying on the ground, so it's decomposing or may exist in a deadwood pool. But the soil carbon in particular here, and Lauren may touch on this in a bit, so that's the big one. We know that through land conversions, soil carbon does change. And it's important to note that a lot of the soil carbon, however, is transferred to the new land use category. And how that land use is, for example, if we move from forest land to agriculture, tilling practices are likely to lead to an emission of soil carbon back to the atmosphere relative to what that soil carbon was like while it was an intact forest. So that's where a lot of the emissions come from outside of those trees being removed. There's also a lot of the carbon that's transferred is in the soil carbon pool, and land use practices will really drive how that soil carbon, whether it persists on the landscape or is lost through lateral transport or back to the atmosphere.
Okay, so I think I want to make sure we transition to sort of the differences here, because we have forest land, remaining forest land as a single bar. And I think one of the things that we have a lot of interest in the building sector is understanding how we might influence forest lands to be more carbon storing and more carbon removaling. And so, you know, here you're talking about, in this slide, you talk about different ownership structures and the different ownership structures. You're just taking the data that you've measured based on different ownership structures to figure out over these time periods what is happening in these different ownership structures. Is that?
Yeah, so the top graphic here again reflects a static point in time, but now rather than being a population estimate over the nation, these are estimates at an individual hectare. So per hectare in the US, by stocking class, so how many trees exist on these different classes, we're looking at the amount of carbon in live trees that's accumulated. So the carbon stock by these stocking classes across federal, state and local, and private ownerships. And so you can see that fully stocked and overstocked stands, not surprisingly, have the most accumulated carbon over time. Whereas poorly stocked and non-stocked forest land doesn't have nearly as much carbon, in large part because there aren't as many trees occupying the same space. So that's the main reason. So that's the stock side of this story. The other side, and so those estimates are compiled using a single point in time to get a static picture of what does the current accumulated carbon in that forest per unit area at a given point in time. The graphic below, which is negative, reflects the net annual change. So the sequestration in live trees or the carbon accumulated through sequestration or growth per unit area. And so quite a bit different. This requires two measurements of the same plot in the same tree, and any trees that die or are removed is captured here. So this is the net change in just live tree sequestration. And so you can see.
And so we'd want a big bar in this one, right? We'd want a big bar.
The bigger, the greater the contribution. And so one of the things that we've been working on in Forest Service right now is looking at, hey, there's 33 million hectares of understocked, which means poorly stocked or non-stocked forest in the US. Look at how much carbon there currently is standing on those forests, and look at if we were to replant or supplementally plant those sites, the sequestration benefit of fully stocking those sites, but also the carbon that could accumulate on those sites relative to if they were not fully stocked. So this is really, not only does it reflect things by ownership, but it also really reflects potential opportunities if you combine this with the amount of understocked productive forest land in the US.
So I think I want to switch this to Lauren right before we got onto the talk here. Lauren, you had some really interesting slides that you were starting to show about, we want to get to the question, how do we incentivize increases in this flux? Does sustainable certification, oops, I'm going to stop my share. What can we tell about certification? Does that lead to this confidence that we're increasing the flux or not? And are there differences in certification? I'm kind of throwing a whole bunch of questions at you. I'd like to have
yeah, I mean, I think that the questions are, these types of questions, and specifically about carbon, are certainly very timely, and I think that there's a lot of interest in continuing to explore them. But I think they fundamentally point to a lot of research questions. So we don't have a lot of there's just a really great deal of variation in forest ecosystem types. And so it's kind of difficult to make super clear comparisons. And I touched on this last week as well, that you could have somebody implementing good practices but not be certified. So that's the reason for the different types of certification standards. Also the fiber sourcing that allows for inclusion of responsibly sourced materials entering the certification stream, because there are good practices being implemented that aren't necessarily branded certified. But the fundamental idea with certification is that we know that it's a way of getting more users, more landowners and decision makers to be aware of and implementing what are called BMPs, these best practices. And again, I touched on this last week, but those best management practices are not required in every state. And so in some states they are required, in some states they're voluntary. And what certification does is it gets more actors using these BMPs in the state of Michigan, for example. And there can be questions about, there certainly has been questions comparing some of the major standards, and there's different aspects that folks might look at that could have carbon and climate implications. But overall, just recall that we're talking about certification on the working forest lands, and that we're not suggesting that all forests become these working forest lands, but thinking in a conversation earlier, Grant used this term, a portfolio approach, which I also refer to as like a landscape approach of recognizing that in terms of sustainable thinking, we need materials. Everyone on this call knows that. That's why you're part of this consortium, that we need to build things, we need materials. So with a climate umbrella, we have to think more broadly about what does that really mean, and thinking about renewable resources and forestry as part of that, as what should be a core part of that portfolio. And that certification provides that baseline level of best practices that may not be, that may be beyond regulatory requirements. And I can share these few slides here of these kind of core concepts.
Yeah, because I kind of want to get on specifics. Like, I want to know if, Grant was showing those slides with the change in flux by different measured on different ownership structures. How do we? Oh yeah, this is good. Do we want to do all of these things? I can't see.
Can you see my screen?
Okay, I would say that. Yeah, so I would say that that item 1 and 2 are non-controversial statements, and some people would say they don't come to the conclusion that 3 is founded, right? So that, I think, I'm just being direct here, right?
Oh, great, it's great. No, so I think that this is where there gets to be this kind of portfolio approach or looking across a landscape. So yeah, 1, sure, it's not controversial. And I mean, not here necessarily. This can be very challenging, but avoiding, forest loss, not controversial. This maintaining or increasing carbon stocks can be tightly related to this increased wood use, because when you're looking at a portfolio or landscape approach, you may be looking at increasing carbon stocks in the living or in the various forest carbon pools on the landscape. But you can also be targeting certain parts of the landscape for high productivity, where you would be transferring that carbon to that harvested wood product pool. So you would not only be storing the carbon in the wood products, but you'd also be substituting more emission intensive materials to undertake activities that we need to undertake to build buildings and use materials. So I know that's been touched on a little bit. So I have a kind of a slide here. This is obviously the one that's less controversial, but again, these two can be interlinked. So you can maintain or increase carbon stocks across a range of forested landscapes, but when you're looking specifically at your productive landscapes, this number 3 can come in as an important component as well. And again, this is the non-controversial one, but just to back up Grant mentioning what happens with conversion, you have the immediate loss of carbon from the above ground biomass loss, but then you'll over time continue to lose soil carbon. So a lot of studies have shown that you'll continue to lose soil carbon for around like 2 decades after you lose that initial carbon loss. And that just points to the in many areas, rich pools of carbon in soil. And so just how damaging this can be. But this can also happen even when you're changing from more complex forests or natural forests to more intensely managed forests, can also result in losses to various pools, even litter that is getting disrupted. So this is kind of an important component. But here's kind of getting to this idea of this, of valuing carbon across the landscape. And I know some of the questions were about if this is included currently in certification, and this is one of the topics that's coming up more. I know that SFI is currently revising their standard and has a really large stakeholder engagement process for that. So if you're interested in learning more about it, I know that is an ongoing process right now, but they're adding in more considerations for carbon and for climate. And so this is a kind of an example of where you could have planning around high carbon stock densities. And so these would occur when you have enhanced carbon inputs, but you have conditions that reduce carbon loss. So you might have wetlands or boreal forests that have a certain temperature that limits the natural process of breakdown and release of that carbon. So in kind of future looking, we may be looking at, and I know kind of states are starting to think about this as well, thinking about managing at a high level across the landscape level. How can you identify areas that are appropriate for your more intensive productive landscapes that are going to have lower, and it depends on your forest cover type, but in theory would have lower above ground carbon average on that landscape because it's being harvested more intensely, but it's going to have more carbon going into a harvested wood product pool, where you might have areas that are identified as having as high carbon stock densities that could be very low risk for carbon losses that you would identify as not going to be a highly managed area. So you might manage it for pests or for forest health, but not for heavy harvesting. And so that area could be targeted for higher carbon storage on that on the landscape. And so looking at a kind of higher level approach, how would you ensure that you over time don't have any, going back to Grant's tables, that you're maintaining forest health, you're maintaining these various stocks and pools so that over time you're maintaining that sequestration. Because the other major point is that older forests, when you have more mature forests, you end up reducing your overall sequestration because the trees, you have more mature trees. So trees have their optimal growing phase where they sequester a lot. So in the other carbon pools, in those growing forests, their sequestration rate might be high, but the pool of carbon, above ground carbon, might be lower. Whereas in an older growth forest, the sequestration rate might be lower, but the overall carbon storage on that landscape will be higher. And so that, again, it's a range of goals, a range of values in terms of carbon. So both the values of the wood products that we need and use, but also that they can have these carbon benefits. So here's just some other kind of approaches thinking about targeting high carbon value areas. So sites that are have low vulnerability to carbon loss. That might be the appropriate ones for maintaining high carbon density. Where we know areas that are at higher risk for disturbance. So this is another kind of question that came up about carbon loss due to disturbance, so fire and pests. When you have those areas that might be at higher risk for disturbance, those could be areas that you identify for management, because they're not guaranteed long-term stores of carbon as they are. So these are the types of things that people that in various DNRs or in these certification bodies are trying to think about this additional lens of forest management in terms of this carbon piece.
And could we combine the kind of forest surveys, like the FIA surveys that Grant's talking about, with certification, so that you could have a landscape model that, if I'm purchasing from a certain supplier, that I know that they have a net increase, their flux is higher, that they're carbon positive in some sort of way. Is there a way that we could take measurements or take aerial photographs and model that into something that could add sort of a carbon number that came with a certification? Is that something that's possible?
I mean, technically the idea of these forest inventory, so anyone that's producing timber at scale has pretty advanced forest inventory going on, that it's pretty somewhat straightforward to translate forest inventory into carbon, particularly in knowing what's going into harvested product pools. It would require an additional layer of information to think about these risks, like where you would target these areas for higher carbon storage. But certainly, some of the earliest actors in the California carbon market have been timber companies, because they have the data, they have the practices, they have the land. So it's so they're already able to look at, okay, how are we managing the landscape? What could we do that's slightly different? What changes could we make so we're still able to produce products, we're certified sustainable, but we're able to slightly increase the amount of carbon stored on the landscape, and that's how they engage in those carbon projects. So it's certainly possible, and currently that information is not required as part of a certification standard, but I think that we're seeing increased likelihood that carbon conversation is going to be coming into that sustainability piece as you're touching on.
And so it seems like one of the challenges there would be, where do you draw the boundary of your system that you're tracking the carbon flows from, right? So that we've got the whole US, or we can do a state, or you can pick management. Grant, I mean, I imagine that's sort of one of the interesting challenges of the data. Would you agree that I mean, it seems like depending on how you define your plot of land, you could come up with a different answer based on what your harvesting is. I mean, it's simple if you just have the state of Washington, but like a landowner that harvests in many different regions.
Yeah, no, certainly scaling these things is an emerging area. I think it requires really a data fusion approach where we combine, as Lauren mentioned, local entity level inventories with more strategic level inventories like FIA, as well as remotely sensed information. And collectively with all of that, combined with a variety of simulation tools, we can really start to get at entity level estimation. And from my perspective, it's important that these different scales are really aligned. So we paint ourselves in trying to resolve or disaggregate the national level statistics that we talked about early on in the call today as fine as individual county level. We don't really feel comfortable with the FIA data alone going smaller than an individual county. Of course, some counties, particularly in the Western US, are quite large, so it's possible in those cases. But really it becomes a sample size issue. And that's where we start to think about, okay, how can we harmonize those data with remotely sensed information and then bring in models to allow us to look at sort of entity level scenarios but that align with the estimates that we would compile, say, at the county or at the state or at a national level. That sort of consistency and continuity, at least within our group, has been really important, and we've really worked hard to ensure that we can do that, or at least provide the kind of information that's necessary to do sort of even entity level reporting, but making sure that it's consistent with the way that we roll things up at a national scale.
Okay, and I could keep going because I have some other questions for Lauren, but I want to make sure we get to some of the EC3 specific stuff. So I think the key outstanding, maybe I'm going to make a statement, and I want to see if you agree with me. We want to be able to take carbon flux data from the landscape management scale and assign values to it, and as we interpret LCA data in buildings. And as I've asked around, I don't find anybody that has definitive data that links that different management or certification schemes can explicitly be connected to increasing the amount of carbon flux. Is that true?
At this point, so it's just very timely conversation. I know of some major studies that are going on right now that are 3 big studies that are happening right now asking those types of questions. So they're very timely. They're looking at certain regions and specific areas, certain context. There's other big kind of unknowns, like how far materials ship, so transportation emissions. So there's just a lot of variables and questions about some of that. But we know that when you're looking at wood materials in comparison to when they're substituting materials that we know are extremely emissions intensive, like concrete and steel, we can really when you're making comparisons, that there's you're looking at a renewable resource.
But we're not doing that one right now. We're not doing that one right now. So we're wanting to compare between wood products and which one is getting us the answer. So we don't have that data yet, is what you're telling us. But we have heard definitively that if we know that the wood is sustainably sourced, that is the first best path towards that.
Right.
So I'm going to just, and so Grant, on the Forest Service data, that storing it over time is what keeps it longer in your chart, right? You kind of, if you assume it goes to a wood product, you give it a life and you keep it, you assume it's there over a longer period of time, right?
Exactly. It has a half-life. So in the case of housing materials, that might start in the year 1900, and based on the half-life, the period at which it all returns to the atmosphere, that's why you get that accumulation over time.
So if I'm a building owner, I really could, that my benefit is that I've kept it over time, not that I put it there to the beginning. So if I make a massive building and I only let it stay there for a year and then I burn it up, like Burning Man. Let's use the Burning Man example. I make a really carbon storing Burning Man tower and then I burn it up over the year. There's no benefit really from a carbon storing perspective. It maybe could be carbon neutral if I'm managing it from a sustainably ignored forest, but I don't get this carbon benefit. So I'm kind of wondering what maybe the carbon credit is you only get it after you've kept it over time. Like if you're thinking of it from a building owner perspective, it's the fact that you've maintained this long life product that you would get the value. So it's sort of almost like a potential future benefit of this carbon stored.
Yeah,
does that make any sense?
Yeah, that's right. And that's the way we see it. And also, I think this is an emerging area where in a lot of cases, the half-lives that we have in terms of the residence time, on Earth, before it returns to the atmosphere, we don't have good information because the products are emerging so quickly. We don't really know how to assign these new half-lives. And even thinking, this gets really sort of technical, but we just assume sort of this exponential decay. So maybe it's a different model form altogether with some of these new products that are being developed. And that's something that, we're beginning to explore, but that requires a lot of time and real experimentation to get a better handle on how a standard 2x4 of a particular species compares to some alternative wood product that might have twice the half-life of that product, depending upon how it's used. And so, recycling is an important component as well. But generally speaking, I think that's a very good point that you raise. And given the way that we compile and consider the long-term storage of wood in things like homes and other products, getting a better understanding of these new emerging technologies and how long and what the potential uses are, maybe even secondary uses after some primary use, is really critical in sort of incorporating that in both the stock estimates, but also our flux estimates.
So that's sort of pointing to some some qualitative guidance about, let's use our buildings a long time. Let's reuse the materials that we have in them. Those are general circularity principles that that flow into that. And so we can see that some of these estimates, the calculation of them is difficult to do because we don't even know how long buildings are lasting. I mean, and that they change based on how we choose to use our building stock and what we do to it, maintaining it versus demolishing it. So I'm kind of, this is sort of off. Oh, we're at time. Oh, dang, we're at time. I wanted to get into short rotation crops and the difference that it might be for short rotation crops and compared to long wood products, because I think there's some really interesting differences there in terms of things that might have been combusted right away, waste products. But we do not have time to do this. So I want to thank all three of you for joining us today. I want to thank all the participants who've been on the call. I'm going to just keep going, Monica. So we've got a next round of presentations next week, and then our concluding list of presenters. I want to acknowledge that this project has been supported as part of the methodology development for the embodied carbon and construction calculator. That's a free open access tool, so you're welcome to go in there and check it out. Thank you for all of those sponsors for making that possible, and thanks again to Lauren, Grant, and Maggie for sharing their time and knowledge. And I hope everybody has a great day.
Great, thank you so much.